Hello viewers, today we're going to look at a question on square numbers. This is the question: find the perfect 4-digit square number which is of this form AABB, right? So the first 2 digits are each equal to A, to the digit A, and the next 2 digits are each equal to the number B. Now how do we systematically go about doing this? That's the question. Now we can write AABB in the expanded form in this way. This is 1000 times A plus 100 times A plus 10 times B plus B, or 1100 times A plus 11 times B. So it's pretty obvious that this number is going to be divisible by 11, right? So A, B, B divided by 11 is going to be 100 times A plus B, right? Now for AABB to be a perfect square, because 11 is not a perfect square, for this number to be a perfect square, 100A plus B should be divisible by 11 again, right? So 100A plus B, when we divide this by 11, we would get, this can be written as 99A plus A plus B divided by 11. So that would be 99A by 11, which is 9A, plus A plus B by 11, right? So this clearly means that for this number AABB to be a perfect square, A plus B has to be a multiple of 11. Why? Because this is perfectly divisible by 11, and because 11 is not a perfect square, this quotient has to be again divisible by 11. If it were not, then this cannot be a perfect square, because it's only divisible by 11 once. It cannot be a perfect square if that were the case. So that quotient has to be divisible by 11 again, and this is the quotient again. So this quotient has to be a perfect square, and it also has to be divisible by A plus B. The sum A plus B has to be divisible by 11, otherwise this wouldn't be even an integer, right? Positive integer. So now A plus B has to be divisible by 11, right? And this result has to be a perfect square. That is 100 times A plus B, when it is divided by 11, that quotient has to be a perfect square. So let's now look at the possible choices for the numbers or the digits A and B. Right? We can't start with A is equal to 1, then B would be 10, right? Because A plus B has to be divisible by 11. Then we would end up with a 6-digit number, not a 4-digit number. So we have to start with the minimum value of A as 2, in which case B would be 9, right? Because 2 plus 9 is, that would be divisible by 11. Now 100 times 2, which is 200, plus 9 is 209, divisible by 11, divided by 11, the result would be 19. So in this case, 2299 can be written as 11 into 19, right? 19 is not a perfect square, so this is not the number that we are looking for, because this quotient also has to be a perfect square. The next choice for A would be 3, in which case B has to be 8, because 3 plus 8 is 11, which would make A plus B divisible by 11, that is 11 divisible by 11 itself. We observe that here A has increased from 2 to 3, which is an increase by 1, and B has decreased by the same amount, which is 1. So what we would get here is 308 divided by 11. So we would expect a similar pattern here, because there is no 10th, the 10th place value is 0, right? Because it's 100 times A plus B. So we would expect this increase, which is an increase here by 1 and a decrease here by 1, which is 28. right? So we can, again, 28 is not a perfect square, so 3388 is not the number that we are looking for. So we could carry this forward. 47, right? 407 divided by 11. This would make it 37. 56 should make it 506 divided by 11, which is 46. We observe that 46 is again not a perfect square, but 64 is, right? So, if we had 6 and 5 here, we would have 605 divided by 11. That would be 55, right? 7 and a 4. That would make it 704. This would be 64, which is a perfect square. Of course, the next two choices can also be written down. 8 and 3, which is 803 divided by 11, which is obviously 73. And 9 and 2, that is 902 divided by 11, which would make it 82. So when we observe this, we find that 64 is the only perfect square, and all the others are not. All the other quotients are not. So, which happens when we have A is equal to 7 and B is equal to 4. So this is the number that we are looking for, which means that we are looking at 7744. We can do a cross verification. We can divide this by 11, right? So we get 77. Of course, that'd be a 0. 44. So this we would get 704, which is what we are expecting here. Because now 704 when divided by 11, so 6, that'd be 66. The remainder is 4, 44. So the quotient would be 64, which is what we were expecting as per these calculations as well. So all that this goes to say is 7744 can be expressed as 11 into 11 into 64, because we are dividing by 11 twice, and then the quotient here is 64, right? So if we took the square root of this number, that would be the square root of this as well. Of course, square root of 11 into 11 is 11, and square root of 64 is 8, or in other words, 88 squared is 7744. So this is the only number which satisfies all the conditions specified in this problem. Hope you like this video. Please subscribe to our channel and tune in for looking at our previous videos as well as our upcoming series of videos. Thanks.